In today's video, we will be talking about bounded sequence. Okay, so yesterday's video, in the previous video, we talked about what do we mean by limit of a sequence. So before we proceed further, let's know what are bounded sequence. So suppose xn is a sequence, and if there exists a number m, positive number, such that mod of xn is less than equal to m, then we say that the sequence is bounded. Okay, suppose xn is less than equal to m, not mod of xn. Mod of x is less than equal to m implies minus m less than xn less than m. That is, it is bounded below by minus m and bounded above by m. Okay, so bounded below by minus m and bounded above by m. Suppose xn is less than equal to xn is less than equal to m, then we say that xn is bounded. BDE means bounded above and not bounded below. Okay, and if this happens, then we say that xn is bounded below. And in the case when both of these happen simultaneously, then we say that xn is bounded. For example, minus 1 to the power n. Minus 1 to the power n, we can write it as minus 1, 1, minus 1. So, minus 1 less than minus 1 to the power n less than equal to n. So, minus 1 to the power n is bounded by minus 1, bounded below by minus 1 and bounded above by 1. So, minus 1 to the power n is a bounded sequence. Okay. Now that we know what is bounded sequence, we can prove a theorem that is a convergent sequence can have a convergent sequence is bounded. But before that, we have another theorem. Suppose xn converges to L, then we have to show that this L is unique. Okay, so how do we show that? So a sequence can have at most one limit. So proof. Suppose what we assume the contrary. So suppose L1, okay, let's denote the sequence. Suppose xn be the sequence, and then what we assume, and we assume that the sequence has two limit, L1 and L2. L1 and L2 be the two limits. What do we need to show? We need to show that the sequence is unique limit. So how do we show that? There are several ways we can show that. Suppose we can show that L1 minus L2 is less than epsilon. Then what is epsilon? Epsilon is greater than 0, and epsilon is any arbitrary number. So if it is less than epsilon, that means it is we can take epsilon to be 0.1, we can take epsilon to be 0.001, 0.0001. That means as close as possible to 0. So if this happens, we can say that L1 minus L2, L1 equals to L2, that is L1 minus L2 equals to 0, or L1 equals to L2. So you will use this process. Okay. So now what? Xn has limit L1. So by our definition, given epsilon greater than 0, there exists k such that what? Such that mod of xn minus L1 is less than epsilon by 2. Okay, it is not that we have to take epsilon. We can take any variant of epsilon. I have taken epsilon by 2. You can choose epsilon by 3. Okay, and also this is xn belongs to L1 xn, and then we have xn converges to L2. That will implies that same way. This is k1, and let's take it k2 for all n greater than equal to k1, and this happens for all n L2 less than epsilon by 2 for all k and greater than equal to k2. Hmm. Let's see this graphically. Where suppose this is a sequence and this is a limit. So after k1, this goes to this. Okay, let's name it L1. And suppose this is not possible actually to have two limits, but suppose it has two limits, L2, then uh, it will be like this. Okay, and this is our k2. If we take it this to be epsilon by 2, k2, and this happens for at less than k greater than equal to k1. So what is the maximum for this? This will also happen and this will also happen. So we take k to be the maximum of k1 and k2. We write this, let k equals to maximum of k1 k2. Then for n greater than equal to k, both of these happens. Okay, xn minus L1 is less than epsilon by 2 and xn minus L2 less than epsilon by 2. Now consider mod of L1 minus mod of L2. We can write this way, ln minus xn plus xn minus L2, right? So this cancels out and we get again L1 minus L2. Now this is less than equal to L1 minus xn plus xn minus L2. What is this? This is the triangular inequality. Okay, triangular inequality. Now xn minus L1 is less than epsilon by 2. So L1 minus xn, we can write it as xn minus L1. So xn minus L1 is less than epsilon by 2. Xn minus L2 is also less than epsilon by 2. And if we add, we get epsilon. And epsilon is what? Epsilon greater than 0 is arbitrary. So what do we have? Since this is arbitrary, this implies L1 minus L2 equals to 0 or L1 equals to L2. So we get what? That if we have two different limits, then the limits are actually same. We cannot have two different limits. Okay. In the next video, I will discuss this theorem and its proof that a convergent sequence is bounded. Thank you.